Let's see. All right, I think we are live.
Let's go.
Let's see. All right, I think we are live.
Let's go.
तेरी आवाज बस एको हो रही है उसमें स्ट्रीम में पता नहीं क्यों. ओ आई नो
Mm,
क्यों हो रही है. अब नहीं होगी. बोलना एक बार
mm,
टेस्ट.
test.
को हो रही है उसमें स्ट्रीम में पता नहीं क्यों.
Check, check, check. 1 2 1 2 1 2.
ओ आई नो क्यों हो रही है. अब नहीं होगी. बोलना एक बार टेस्ट.
Test.
को हो रही है उसमें स्ट्रीम में पता नहीं क्यों.
Check, check, check. 1 2 1 2 1 2.
ओ आई अभी भी हो रही है. अब नहीं होगी. बोलना एक बार टेस्ट.
Test.
हम्म. को क्यों हो रही है आवाज. ओ आई थिंक आई नो क्यों हो रही है.
Mm.
ऑडियो कैप्चर. हेलो. अब बोलना टेस्ट.
Check. 1 2 1 2.
हो गया सही. Correct. All right. Welcome back to day 59 of OpenUSD certification. We were on extracting data extraction in the data exchange pipelines. Mhm. So, where do we start from?
I think, yeah, from the place where we left. Yeah, right over here, I would say.
So, let me read it once. Now that we have a way to parse the data into our OBJ file, we can start extracting the information and translating it into OpenUSD. When parsing through each mesh in the scene, we need to make sure the mesh name can be used as an identifier or prim name. Let's add Tools Foundation library to our PXR imports, and at the top of the file, add TF to the list of imports from PXR. It should look like this. Next, let's add extract method right underneath where we define the stage. Before we call return stage, we'll add our initial loop to go through all meshes in the scene. In OpenUSD, we need to ensure the mesh identifier is valid before we define it in our stage. Pay attention to our indentations if you're copying and pasting, all right. So for mesh in scene meshes, replace any invalid characters with underscores. Sanitize. Oh, this was one of the questions. Do you remember? TF dot make valid identifier.
Yeah, I do remember it. It
Replace
basically,
any invalid characters with underscores.
yeah, yeah, I do remember it
TF
vividly.
make valid identifier. Based on our diagram below, we'll first extract the vertex indices of the face and number of vertices. Based on the diagram below, we'll first extract the vertex indices of the face and the number of vertices of each face from our object. Okay, vertex points, texture coordinates, primvar st. So texture coordinates are primvar st, vertex normals is normals, primvars normals. Face is face vertex indices and face vertex counts. Still within our loop, we'll create another loop to go through each vertex index for each mesh. Within our loop, we'll create another loop to go through each vertex index. First of all, let me just for myself get a clarification on what is the difference between a vertex and an indice. So vertex are the points.
Yes.
Why did I
And
forget this?
indices are like index.
Oh, this is Vulkan. This is related to the 3D thing.
Yeah.
So vertex, bro, I just need a fucking diagram that shows what is vertex. Okay, so vertex, edge. So indices are edge or no?
Indices are index. Index. Indices are index.
What index?
0, 1, 2, 3 index. So vertex. So in ask it on in OpenUSD what are indices? You have to ask that question over there. Indices not in geometry. In geometry, indices does not exist. Yes. Index is indices.
Indices primarily refer to either geometry indices, defining face vertex on meshes, index primars, optimizing data array like normal, color, okay. So indices are just so face vertex indices and face vertex counts. So face vertex indices are 0, 1, 2, 3 index for the vertex, and face
Yes.
vertex counts are like the number of vertices.
Yes.
You can, okay. Still within our loop, we'll create another loop to go through each vertex index for each mesh. This allows us to assemble both the face vertex indices and the face vertex count arrays for USD geom.mesh. Add the following code underneath where we define USD mesh. Okay, you can use the VT APIs. VT APIs here instead of Python lists. Especially keep this in mind for C++ implementations, face vertex counts, face vertex indices. For indices in mesh.indices. Okay, so here's the first loop, for loop, for indices in mesh.indices. What is mesh.indices over here? The indices of the VT points in the mesh of the OBJ file, right?
What?
I'm asking what is mesh.indices over here.
Mm-hmm.
So I'm saying mesh.indices is the index of the vertices of the OBJ file.
Yes.
Is that the one?
Yes.
Okay, and convert the index.
Of the vertex.
What?
The indices that we are referring over here contains the vertex. Indices are just a naming convention that
Mm-hmm.
refers what are the vertex points basically like
Mm-hmm.
what So when you traverse through
Mm-hmm.
those indices, you will find vertex points
Mm-hmm.
basically. So that's why face vertex indices dot extend indices. So
Mm-hmm.
whenever you are getting an indices array, you are basically extending it
Mm-hmm. Okay.
and flattening it into a single array of face vertex indices,
Mm-hmm.
because that's how OpenUSD loads it.
Okay. So for indices in mesh dot indices, face vertex indices dot extend indices. Convert the indices to a flat list. Okay, so they are so face vertex indices dot extend is gonna convert it into a flat list.
Face vertex, yeah, it's gonna convert it into a flat list.
Okay. Append the number of vertices for each face. Append the number of vertices for each face. Okay, so face vertex count dot append length of indices. So face vertex indices dot extend is gonna uh, create it into a flat list. So this is the OBJ and this is the points. So this is getting converted into this points, right? And then face indices is getting converted into a flat list 0, 1, 2, 0, 2, 3.
Yes.
So face and then this is F1, F2. Face vertex counts is
Yeah,
F1,
the length
F2.
of indices that they have. Face vertex count is length of indices.
Face vertex counts is length of indices.
F1, F2.
Okay. Both OBJ and OpenUSD lists of vertices, store lists of vertices and lists of faces that reference their member vertices by index. OBJ keeps one global list of vertices for all objects, whereas OpenUSD tracks the vertices on per mesh basis. Fortunately, ASIMP has already taken care of mapping the global vertices of OBJ to per mesh. Another difference to note is that indices from OBJ are grouped on per phase basis, but OpenUSD prefers to flatten list indices that can be recomposed into phases. What does that mean? Another damn. Fortunately, ASIMP has already taken care of the mapping of global vertices to of OBJ to per mesh. Another difference to note is that indices from OBJ are grouped on per phase basis. Okay. But OpenUSD prefers a flattened list of indices that can be recomposed into phases using an ordered list of face vertex counts. Okay, so okay. For an example, compare faces and face vertex indices arrays in the image above. Faces and face vertex indices. Okay. This code accomplishes two things. It flattens the per face indices into one continuous list. Okay. So this is converted into this, and for each face it counts how many indices it's made up of. For each face it counts how many indices it's made up to populate the list of the face vertex counts. I see. So 1, 2, 3, so length is fed into face vertex counts as first phase, and then 1, 2, 3 is second phase. Now with the rest of information from ASIM, we can create attributes to define the points, faces and normals of the meshes. Now with the rest of the information from ASIM, we can create the attributes to define the points, faces and normals of the meshes in OpenUSD. Let's add the following code to create these attributes. Place the code after our last loop but not inside it. So USD mesh dot create points attribute mesh dot vertices. USD mesh create face vertex counts attribute dot set. Okay. Place the code after our last loop, not inside it. Okay. So this is creating something USD mesh dot create points attribute mesh dot vertices. So this is creating the mesh dot vertices This is creating the face vertex counts attribute, face vertex count. And then what did you say yesterday? What was the difference that you were telling me about this?
Which part? So the second
USD.
line, that's the default value, default fallback value for that point attribute.
Mm-hmm.
But if you do not initiate with, because since we are not using dot set, so it's gonna set a fallback value. In the
Mm-hmm.
if you create face vertex count attribute directly and you do not pass any value over here, the attribute will be always be empty. So you have to use dot set to set the attribute value by using this. So if you want to avoid using dot set, right, you can directly pass face vertex count inside the counts attribute and it's going to set the default value. If you use this, it's not going to set the default value for face vertex count attribute. That is the difference. So
Mm-hmm.
set and getter method. So set only sets the value. It's not it won't set it as a default value. That is a major difference.
It won't set it as a default value.
Yeah. Dot set won't set it as a default value. It says
Set.
right over there as well. Like if you go down, you will see. Yeah, see the point attribute set by passing a default value and create points attribute.
I see. Sarkar is in the chat.
Crazy.
Say hi.
Tiger is here.
Okay, what were you saying? Set what? Set face vertex counts.
Yes. So it won't set the default fallback value for face vertex counts attribute. It will only set the value for that point of time. So you
Mm-hmm.
in case you remove or somebody comes and says, "Hey, I'm gonna unset the value or override the value," right? And
Mm-hmm.
then you put attribute blocker, right?
Mm-hmm.
And then in that scenario, that face vertex counts goes values goes to none if somebody puts an attribute blocker in that thing.
I see. Hmm. Right into USD step after you've assembled per mesh vertices and face data. Okay. Mm-hmm. Yeah, Clarence. Okay. Oh, now I understand what's happening in the whole. Okay. Hmm. The snippet is the write into USD step after you assembled per mesh vertices and face data from asim slash obj line by line explanation USD mesh dot create points attribute mesh dot vertices creates the points attribute on the USD geom dot mesh and sets its default value to per mesh vertex positions asim gave you mesh dot vertices in USD terms. This is actually geometry's control points. Hmm.
Take a leak and be back.
Mhm. That is USDF make valid identifier, USD mesh, yes. Front wheel, okay. USD geom.mesh.defined actually does USD geom.mesh.sfi. Mm-hmm. Yeah, yes, USD geom. Okay. Related geometry attributes. Hmm. USD mesh dot create points attribute mesh dot vertices USD mesh dot create face vertex count attribute set face vertex count USD mesh dot create face vertex counts. These. Okay, so typed USD prim using mesh schema. At the moment, mesh is empty. It does not have points or faces. So the points then filtered with geometry attributes. USD mesh dot create points attribute mesh dot vertices create face vertex counts attribute dot set face vertex counts USD mesh dot create face vertex indices attribute dot face vertex indices. Those calls author the real mesh data. The most important concept of OBJ face indices was USD face arrays. This is the core of the page. OBJ stores faces grouped like this 0, 1, 2, 0, 2, 3. How many vertices? Okay. Face vertex count is 3, 3, 4. Oh, face vertex count becomes 3, 3, 4. Okay. And the other is face vertex indices become 0, 1, 2, 0, 2, 3, 4, 7, 5, 6, 7. This is exactly what the code does. Why the code does face vertex count. Okay, face vertex indices dot extend indices. Face vertex. Oh, gotcha. That's a gotcha indeed.
What happened?
Mhm. No, I just understood the code. Um, this is part of data extracting geometry. OBJ is phase 1, phase 2, 3 equal 0, 1, 2, 2, 0, 2, 3, 4, 5, 6, 7. USD becomes phase vortex counts base 3, 3, 4 in phase vortex indices becomes 0, 1, 2, 0, 3, 4, 6. Four, four indices. Four indices. Invest indices. Phase vortex indices. Not extend indices. Phase vortex counts is dot append indices. Okay, and then phase vortex indices, flattened list, phase vortex counts, how to split flattened list back into phases. So if we have this, so the list would be 3, 3, 3, 3, and then phases would be 4, 0, 1, 2, 3. Phase vortex counts would be 4. Phase vortex count would be 4. Phase vortex indices is 0, 1, 2, 3. Meaning the actual vortex positions. Points is the actual vortex position. There is one phase that has 4 vertices. One phase that has 4 vertices. Okay. And then the phase uses point 0, 1, 2, 3. Example 2 triangles. Okay. Why mesh dot vertices become point? Okay, so USD mesh create points attribute mesh dot vertices that creates USD points attribute conceptually async mesh vertices. Okay, so create points attribute on mesh dot vertices makes async mesh vertices into USD geom mesh dot USD geom dot mesh points. Okay, why subdivision is none?
Lux.
NVIDIA notes that OBJ and USD both store lists and vertices, list of vertices, and lists of faces that reference vertices by index, but OBJ has a global list while OpenUSD tracks vertices per mesh. ASIMP has already handled the mapping from OBJ's global vertices to per mesh data. Hmm. Oof, 2 new subscribers. Let's go. How many subscribers do we have? 93. 93 subs.
Crazy.
Okay, I think I understand this part. So now USD grade points. Treat the mesh. Why the page mentions 2 ways to set attributes. Why normals are optional. If mesh.normal USD mesh create normals attribute mesh.normals. Treat this as a regular polygon mesh, not subdivision surface. OBJ stores polygonal meshes. It does not inherently mean in this subd mesh. So the converter explicitly tells USD do not smooth or subdivide this as a subdivision surface. Use it as a polygonal geometry. The page says it is done so meshes are explicitly treated as polygonal meshes. Hmm. Use it as polygonal geometry. The page says this is done so the meshes are explicitly treated as polygonal meshes, not subdimeshes. Subdivision scheme is equal to none. OBJ polygon mesh should stay polygonal. Or do not treat it like sub D. What is sub D? What is sub D?
Subdiv-
Did you?
Subdivisional meshes.
But what is that?
So I think, wait, let me remember. I recall it. Sub D, I did read it. Sub D and then cat nulls. No, I don't know. You can just ask. Yeah.
Subdivisional schema defines polygonal meshes. Subdivisional schema defines how polygonal meshes are smoothed and subdivided at render time, typically utilized the Catmull-Clark algorithm. It is primarily configured through the subdivision scheme attribute on USD GeoMesh. But what is that? Hmm. Hmm. Nujabes. Subdivision schema is configured on a mesh using following properties. Subdivision scheme token define the mathematical rule used to subdivide the mesh. Catmull-Clark standard Catmull-Clark. So Catmull-Clark is a algorithm.
Yeah, but it's a subdivisional algorithm similar to subdivision schema. I think it divides the polygon into different small vertices, like in a way that we can maybe use shader APIs to map or material APIs to map on different faces.
Mm-hmm.
Okay, and the most is how polygon meshes are smooth and subdivided. Yes, subdivided render time. Yes, typically utilizing Catmull-Clark, it is primarily configured through subdivision schema attribute.
Hmm. Holy shit. Okay. OBJ polygonal mesh should stay polygonal. Do not treat it like sub D. Why subdivision scheme equal to none is authored. So USD mesh create subdivision scheme attribute USD geom dot token none. Uniform token subdivision scheme equal to none. Meaning treat this as a regular polygonal mesh, not subdivision surface. OBJ stores polygonal meshes. It does not inherently mean this is sub D mesh. So the converter explicitly tells USD, do not smooth slash subdivide this as a subdivision surface. Use it as a polygonal geometry. Page says that this is the meshes are explicitly treated as polygonal meshes, not sub D meshes, because OBJ do does not support sub D meshes. I see. Hmm. Hmm. 1 second. I'll be back. पांबड़ करे पलेटा अत्ते โอเค Hmm. The point attribute is set by passing default values in create points attribute. Face vertex count is set by calling set using USD attribute object returned by create face vertex count attribute. Both are available and valid. Calling set opens up the opportunity to set time samples if you need to. Also note that we are setting the subdivision scheme to USD geom uh, tokens dot none. So that these meshes are explicitly treated as polygonal meshes, not sub-D meshes. Hmm. USD geom dot tokens dot none. Also note that we are setting the subdivision. What does the fucking mean? Okay, while the page mentions two ways to set attributes, the page shows create points attribute mesh dot vertices. Create point and then USD mesh dot create face vertex counts attribute dot set vertex counts set face vertex counts. Both are valid. These two are two style means create points attribute mesh dot vertices, create the attribute and immediately set its default value mesh dot vertices. Okay, and create face vertex counts dot set face vertex counts, create attribute first then call set on the returned USD attribute. Oh, so this is what you were talking about.
What? Yes, yes.
Mm-hmm. So what does that do? USD attribute. So it runs set on USD attributes and then puts that value inside the create face vertex counts attribute.
Yes.
And what is the advantage of that? Like, why are we doing that?
There's no advantage. Like it's just there. Like if you want to, how would you set it then? Like that is something that you have to follow if you want to set your attribute. Otherwise, Python won't do it, and that is a standard protocol and
But we are
procedure.
doing it over here in the first part. We are doing USD mesh dot create points attribute and then mesh dot vertices.
Yeah,
So
that's
there
that's
we are not setting it.
that's where we are trying to set a default value.
Oh,
If
okay.
Yeah, that's the only difference. Now it depends upon the OpenUSD developer.
But do
Does
we
he
need to do both of them? In order,
like what?
so first we'll set the default value.
Anytime you want to override a value, you have to use set. Let's
Mm-hmm.
say you use USD dot mesh create face attribute counts attribute, and instead of using set, you directly pass face vertex counts inside the method, right?
Mm-hmm.
So that will set the default value, right? So if the OpenUSD developer that is trying to work on with wants to set a default value,
Mm-hmm.
then he can do it. If he doesn't want to set a default value, then it's on him. He can directly use setter or getter methods as well.
Mm-hmm. Okay. Setter and getter.
So like, these are typical methods. If you want to get the value, you use get. To set the value, you use set. So once you set the value, like once you put a default value, then it would be difficult for you to unset the value. That is the thing. Like if you want to unset the value, then you have to use a dot set and with some none attribute or something.
Mm-hmm.
That's the only difference.
I see. Okay. Hmm. And similarly for USD mesh dot create face vertex indices attribute set face vertex indices. Here also it will, I think. So these two style means create an attribute and immediately set its default value. Create face vertex counts attribute dot set face vertex counts. Create attribute first, then call set on the returned USD attribute. The page notes that calling set also gives you the opinion or option to author the time samples if needed on USD attribute.
Yes.
Okay, let me write this down. Oh no, momentino.
It says create attribute first and then call set return. So they both are like two styles. Whatever you want to go with, it's fine.
Mm-hmm. Value create attribute. Set default value immediately. Create X attribute. Send outside value. Create attribute. Set value through USDR. Set value comma time. Can also author time samples. Example time sample idea. What the final extracted USD looks like. A simplified extracted mesh might look like. A simplified extracted mesh might look like USDA 1.0 mesh cube. Uh, mm-hmm. The full process in notebook form exercise, extract geometry, convert OBJ mesh. Okay, so I think that was that much. We did this. Okay, we can move on to the next one, extracting materials.
Mhm.
Cool. Just like a quick run through. The goal was to convert OBJ mesh geometry into USD geom.mesh prim.
Mhm.
Pipeline was OBJ file, asym parses OBJ, scene meshes. For each mesh, sanitize mesh name, define USD geom.mesh prim, convert face indices, author USD mesh attribute, preserve normals if present, mark mesh as polygonal, not sub D, save USD stage. The four code chunk conceptually, import USD tools, meaning TF utility tools here used for valid name, stage creation and high-level USD access. USD geom is geometry schemas like mesh. Chunk 2, create the stage. Stage equal to USD dot stage dot create new. Mm-hmm. Create the output USD file in memory. Okay, so this is creating the output memory file. Output
Yes.
file in memory, sorry. That I think the USD file or USDA file. Define one USD mesh per source mesh. So this is what is doing. Each source mesh becomes one USD mesh prim. Convert topology and author attributes. So this is what the topology. Topology basically I think means the number of vertices and faces, right?
No, 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 no. Topology means how they are structuring it.
What do you mean how they are structuring it?
So there will be a design structure of
Mm-hmm.
where the vertices are present.
Like
So
coordinates of the vertices.
yes, and how they're aligned, like with respect to each other's position. So let's say you have a point X on on first quadrant, then you have a point Y on the second quadrant, point Z on
Mm-hmm.
third quadrant, and point A on fourth quadrant. So now this would be a topology that all these points exist in a
Mm-hmm.
certain position relative to each other, and because
Relative
of
to each other, okay. So not exactly the coordinates, but how they are distanced from
yeah,
each other.
yes, like they will
Okay.
always have the same distance
So
across
why
each other.
did okay, so why did we not see the extent part over here? Like the question you remember we have like if there is a like if we keep the topology same and move the faces along a axis, what part of the code or like the structure should
I don't
remain
know, maybe
same?
it would be the next one. I think I did read it somewhere, but I do not remember it thoroughly. And the other thing was when we figured it out using AI only, like that quiz was generated through Claude, and Claude did tell us what is extents.
Okay.
Or maybe it might be somewhere inside the OpenUSD.
Okay. Hmm. So convert topology. So this is converting the topology and authoring or attributes. So for indices in mesh or indices, face vertex indices, extend indices, face vertex counts, append length of indices, and USD mesh dot create points attribute mesh dot vertices. So this is just gonna initiate the default value and create the points, and then this is gonna initiate a list and then put the value inside face vertex counts or inside this one. And then right positions, topology, polygon subdivision behavior and normals. The main gotchas from this page, USD prim name must be valid identifiers. Yes, OBJ and USD both use indexed mesh topology, but USD wants face vertex counts plus flattened face vertex indices. OBJ can have global vertex data, while USD mesh stores points per mesh. Async handles this mapping in the exercise. OBJ is polygonal, so authored subdivision scheme equal to none. Subdivision scheme equal to none. Okay, normals matter visually. Preserve them if the source provides them. This page is only geometry extraction, materials UV, validation, hierarchy transformation, export options are separate page. Final memory phrase, extracting geometry. Read the source mesh array, sanitize names, define USD geom.mesh prims, flatten face topology into USD's face vertex count slash face vertex indices, author points slash normals, and save the stage. I'll just ask quickly, are normals Extents are the bounding box around the object. Okay. An extent is the bounding box of the mesh. This mesh
Mm-hmm.
fits inside this minimum and maximum 3D box. Okay. Extent has two values. All right. Next part. Extracting materials. I think similar to how we extracted the geometry from .obj file, we now extract the materials. This is the last part of the code that will be adding to extract. Okay, this is the same. We'll sanitize the material identifiers. Yes. TF make valid identifier. Let's get each material from the mesh. So scene.materials, material.material index. If not MTL, continue sanitize that name. Mat name TF make valid. Okay, valid identifier MTL name material path SDF dot path. Let's get each material from the mesh. Add the following code to the material and check if it exists before creating the identifier. This will slot underneath where we define if mesh is normal but not inside the statement if this statement. Next, we will create the material prim in our stage that has a shader surface for the material graph and the following code underneath. Material path. Create the material prim. Material is okay. Let me give. That was quick. Hmm. 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 Where were we? Let's get each material from the mesh and add the following code to get the material and check if it exists before creating the identifier. This will slot underneath where we define if mesh normal. Okay, this is done. Next, we will create the material prim in our stage that has a shader surface for the material graph. So, okay, so I've seen this statement multiple places.
Hmm.
A stage that has a shader surface for the material graph. What does a shader surface mean?
So you have a material.
Mm-hmm.
So imagine, open that, open any polygonal mesh network image.
Mm.
Okay, choose any. Yeah, let's go. Not let's go with something that has, like not this one. Go with the one that is, yes, this one. Right.
Mm-hmm.
Now imagine you are imagine this is the sphere, right?
Mm-hmm.
So now you're wrapping it into some kind of material,
Mm-hmm.
right? That material will be mapped on each node of that polygonal mesh
Mm-hmm.
that you are seeing here, right?
Mm-hmm.
Now once you have a material, now you can pick a certain area from that material if you want.
Mm-hmm.
Material can be a cloth, material can be anything,
Mm-hmm.
right? So in OpenUSD, when you have an object, let's say you have this this object, right? Like this
Mm-hmm.
gun, right? You can create a polygonal mapping across this object.
What you
Like
are
in,
you showing something?
yeah, yeah.
What? Wait.
This
Wait 1 second. Yeah. Do it now.
so this, let's say you have this gun,
Yeah.
right? And I will say, hey, let's map this. So
Mm-hmm.
what you will basically create a skeletal map
Yeah.
similar to that weird mesh that you have.
Mm-hmm.
Now, once you have a skeletal map, then I would ask you, hey, let's start covering this object into some kind of material,
Yeah.
right? Right now, this material is basically a plastic material,
Mm-hmm.
right? So that material will exhibit some kind of property.
Mm-hmm.
So let's say that material is plastic, right? What kind of plastic it is? What are the properties it has? What is the rigidity? What is the roughness of that surface? What is
Mm-hmm.
the color of that surface? How thick is that surface? All these things, things would be the property of a material,
Yeah.
right? Now you got it. What is material, right?
Yeah.
You got what is material. Now
Material is
once
something that we are wrapping up that object in.
yeah, wrapping up that polygonal
Mm-hmm.
mesh in,
Okay.
right? Once you have that, now on the top of that, shader comes in. So now you will tell, what does shader do? So shader provides a property in which you can basically shade a small parts, or maybe give some kind of coloring. So let's
Mm-hmm.
say you want to make some parts of that object glow,
Mm-hmm.
right? So you have diffuse color property as over there. Now
Yeah.
let's say you want to surface humidity or moisture on that material, right? So shader will be used to display humidity and moisture for that material.
Mm.
So that droplets or anything that you're seeing, that you would be seeing in when you render an OpenUSD object. So now
Mm-hmm.
let's take a look at any OpenUSD object that is already rendered, and then on Google Images, and in
Now
that
let's
we
do this.
yeah, let's take a look at this. So over here, this is like a basic minimal diagram
Mm-hmm.
of, you have a polygonal mesh, and then on that polygonal mesh you have mapped it with a plane
Mm-hmm.
uh, clothing kind of material. And
Mm-hmm.
once you have done that, you are basically using shader to color that material.
Mm-hmm.
Like you are using shader as a makeup, right?
Mm-hmm.
Material has all the technical properties, like what is the elasticity, how will it act under stress, will it bounce, won't will it expand, something like, and or if it expands, what will the material rigidity would be, right?
Mm-hmm.
and that's why material is different from shader, because if you, let's say, expand, then the color of that material or that object always remains the same. Why? Because it is covered by using shader API or
Mm-hmm.
shader graph. So that is what material graph, shader graph, and shader node defines over
Mm-hmm.
here. That you can pick up each and every node accordingly.
I see. Material. Hmm. Okay. Material extraction. How do I convert OBJ mesh data into USD geo mesh? OBJ mesh data. How do I convert OBJ MTL material data into USD shared material plus USD preview surface, then bind it to the mesh? NVIDIA frames it exactly the way after extracting geometry from the .obj. The exercise now extracts materials and adds the final code to the extract function. Big picture, the process is OBJ mesh has material index. So material index to find material data from scene dot materials. Create USD shade dot materials. Create USD shade dot shader. Set shader type to USD preview surface. Map OBJ MTL material values to shader inputs. Bind material to the mesh. So the conversion target is not just mesh with geometry, it becomes mesh plus bound material plus USD preview surface shader, new imports. So the conversion target is not just mesh with geometry, it becomes mesh plus bound material plus USD preview surface shader. Okay. These words all describe one thing from different angles. A node graph that computes what surface looks like. If you've ever seen a node editor in Blender, substrings Houdini boxes wired together with left to right, that's exactly it. Houdini boxes wired together left to right, that's exactly it. USD just has its own names for the boxes and containers. Let me map the vocabulary, then draw it. Then think of like a kitchen recipe. What does the surface look like? The material is the finished dish you serve. Uh, bind to a model. Okay. Bind to a model. The shader graph is the recipe steps wired together. Each shader node is one step, and surface shader is the final plating step. Okay. Whose result? Whose result the material actually hands off? Here's the whole thing. Material wood. Oh, now I see. Shading network is basically like a bunch of nodes planning the properties of the
Output.
surface
Yes.
of a material.
Yeah.
I see. So Primware reader reads UV coordinates, UV texture, sample, wood.png, RGB surface shader, ID, USD preview surface, output surface, bound to mesh geometry. Now the vocabulary mapped onto that picture. Shader node, a USD shade shader prim. One box, each does single small job. Read UV coordinates, sample texture, compute lighting. It has inputs, knobs and incoming wires and outputs, results. Other nodes can plug into. In the diagram, primware reader, UV texture and surface shader are each one short node, one shader node. Oh, surface shader is a bunch of shader nodes connected to each other. A USD shade shader prim. Shader graph, material graph, same thing. The whole wired up network of those nodes with one node's output feeding the next node's input. It's a directed graph. Data flows one way from the readers and the textures towards the final shader. Shading network is the third synonym you'll see in the docs. There's no special prim called the graph. The graph is just the connections between the shader nodes. Surface shader, shader surface. Okay, the one node at the end of the chain. The one node. Okay, so surface shader is the one node at the end of the chain that processes the final surface looks. Base color, roughness, metallic, etc. It's not special in type. Here it's an ordinary USD preview surface node. Okay, it's special only because its output is the one plugged into the material surface slot. That's the coral box material, a USD shade material prim. Okay, the container that wraps the whole graph and exposes a few labeled output slots called terminals. Outputs surface, outputs displacement, outputs volume. The surface shader connects to output surface, the gray pill. The material is the thing you actually bind to a mesh. The geometry points at the material, never at the individual, at an individual shader. So the chain of meaning is shader nodes wired together into a graph. What is this? Material जो हो गया, the container that wraps one USD shade material, the container that wraps the whole graph and exposes a few labeled output slots called terminals, output surface, output displacement, output volume. The surface shader connects to output surface, the gray pill. The material in this thing you actually bind to a mesh. Geometry points to the material, never at an individual shader. So the chain of meaning is shader nodes wire together into a graph. The graph's final node is the surface shader. Its result lands on the material surface terminal, and the material is what gets bound to the mesh. Material node isn't formal USD vocab. When doc or DCC tools say it, they almost won't mean either the material prim, the container, or just a node in the material graph, which is shader node. So the chain of meaning is shader nodes wired together into a graph, correct?
Mhm.
The graph's final node is the surface shader, correct? Let me write this down. This is something important. I was trying to understand this. Bonus. The graph's final node is surface shader. Its result lands on the material surface terminal. Material is what gets bound to the mesh. Get Material is what gets bound to the mesh. They almost always mean okay. Material node isn't formal USD vocab. Material node isn't formal USD vocab. When docs or DCC tools say it, they almost always mean either the material prim, the container, or just a node in the materials graph, which is a shader node. If it helps anchor it, the lower in the graph, the more raw the data. What gets bound to the material node isn't formal USD. When docs or DCC tools say it, they almost mean either material prim, the container, or just a node in the material graph, which is a shader node. It helps anchor it. The lower in the graph, the more raw the data. UV numbers. Okay, got it. USD preview surface is a standard built-in preview material shader. Hmm. USD preview surface. Common simple PBR shader that most USD viewers render. Common simple PBR shader that most USD viewers. Render. Order is on the way.
Which order, brother?
Gymshark.
Nice.
I don't know how the fuck Amazon has achieved this fucking insane superpower of, 1 day delivery. Like anything else you order from any other website, it's gonna take 10 to 12 days or something like that. Like at
That's
least
why Amazon has launched its own logistics. Like they use AI to track customer spends. Like they would look at the locations and number of users and your ordering history. Based on that, okay, they will basically have the stocks preloaded on your nearby warehouses.
yeah, yeah. We are so one of my factories, we are gonna rent it out to Amazon.
Yes. Yeah, they
And
usually use it.
yeah, for their stuff. That's what's going on right now.
Mhm.
They are very lucrative in like
Yeah.
they need some requirements in the factory, so we're gonna modify the factory for them and rent it out to
Nice.
them. Warehouse in Pithampur. Do you know the largest race course in Asia is in Pithampur?
Oh my god. Race course for what?
Cars, like race course.
Oh, yeah, because I think there is a Tata factory, Tata Motors factory somewhere.
No,
Or
no,
many.
no, bro. Race course. Um, I don't remember what it's called, but racing
Mm-hmm.
track or something. National Automotive Test. Yeah, Natrax, yes. This fucking shit is the largest one in Asia. Unbelievable. What the hell, dude? Natrax in taking infinite time to load. What the hell? You can book it as well, I guess.
Yeah.
This book now. Breaking track. And I think this was made for some sort of laundering, money laundering.
Mm.
Initially, yes.
Yeah.
High speed track. Yeah, this one.
Mm.
Insanity. Khandava. Beautiful names. Okay. USD preview surface. Why were we talking about that, bro?
Because of Amazon warehouse.
Oh, yeah.
Yeah.
Mental model. Mhm. Okay. It is used when you want your USD assets to have portable material preview across tools like USDB, Omniverse, Houdini, Maya, USD Blender, USD, etc. NVIDIA Study Guide also treats USD material assignment and material binding, as core visualization topics. Think of USD material like small node graph. 1 to 1 ratio. 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 1 think of USD materials like a small node graph. Material connects to USD preview surface shader, has inputs diffuse color, roughness, metallic, opacity. So the shader is the thing that says what color is the surface, how shiny it is. Is it metallic? Is it transparent? Basic USD example. Okay. Def scope looks, def material, red plastic, token output, surface, dot connect. Uh-huh. Preview shader dot output surface. Token output, surface, connect. Def shaders, preview shader dot outputs, preview shader dot output on surface. USD preview surface, preview shader dot output. I see. Def shader, preview shader. Holy shit. The token output surface. Def material, red plastic, creates a USD material. Okay, so this is a USD material till here. So this is what is getting bound to the looks and material binding. Looks red plastic. I see. Def shader preview surface creates a shader node inside the material. So def shader preview shader creates a shader node. Uniform token info ID is set to USD preview surface shader. Creates a shader node inside the material. USD token info preview shader says this shader node uses the USD preview surface shader definition. Then, okay, so over here, when we are defining that, okay, uniform token info ID is equal to USD preview surface, then that unlocks this kind of pattern inside that material, right?
What are we defining? US uniform token ID, info ID, previews. Yes, yes, yes,
So
yes.
because we have written this, we are able to define the properties of that material or that shader like this.
So because of that USD preview surface only, you are able to define those namespace nodes.
Yeah,
Like it creates.
exactly.
Yes.
They are in the schema basically.
Yeah, yeah, definitely they are in the schema. Yeah,
Blueprint,
that.
okay. Okay, this shader node uses the USD preview surface shader definitions. Color 3F blah 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 means red color somewhat so smooth, okay. And token output surface dot connect. Output surface, token output surface dot connect. World looks red plastic USD previews shader dot output surface connects the material surface output to the shader surface output. Connects the material surface output to the shader surface output. Material surface output to the shader surface. Material binding world/world/look/red plastic binds that material to the mesh. Connects the material surface output to the shader's output. Rel material binding world. Okay, binds that material to the mesh. So cube material binding looks for info ID. Okay, so the mesh does not directly store in the shader values. The mesh points to the material and the material points to the shader. The mesh points to the material and the material points to the shader. The mesh points to the material. The mesh points to the material and the material points to the shader. Yes, got it.
Points to the material and the material points to the shader. That
Yeah.
creates a connectable API connection where the shader inputs the nodes directly from the material that we're defining over there.
hmm So material binding looks red plastic material output surface connect. Looks red plastic preview shader info ID USD preview surface. Imports this so the mesh does not directly store the shader values. The mesh points to the material and the material points to the shader. Okay. I think I get it.
Mm.
And then Python example is something we are not gonna look at right now, but texture example.
So you have to look at the Python example, otherwise, because that's the question. That's how the question
No,
will be.
this is not something that is in the this is just an example given by ChatGPT.
No, but just
Th-
go through one. Just go through the code once.
Okay, so they are doing stage, create new mesh, create mesh which is cube. Oh no, they are just defining a cube, creating a material USD shade dot material dot define. Create shader equals to USD shader dot shade dot shader dot define. Okay, preview shader, create ID attribute USD preview surface. So why are we not using USD shade dot USD preview surface? Oh, why is
You
this not
first,
used as an API?
it's not an API. Who said it's an API?
Something like USD shade.
No, no, it's not an API. It's an attribute. That's why that
But
attribute
if
has
this is an
property.
attribute, how can this define a schema over here? Like, if this is a attribute, then how is it defining the schema over here?
So that attribute has properties. First of all, it's an ID attribute, not a normal attribute. Take a look at that.
What does
It's
an
an
ID
ID.
attribute mean?
So you can create custom attributes. So like if you go down, if you
Mm-hmm.
go down into the code, go down into the code.
Mm-hmm.
Yes, yeah, right over here. So you are using this preview USD preview surface, right? And
Mm-hmm.
you are creating this ID attribute. Why? Because that this is the input that your shader will take from your material node. Because your material node will be connected to your shader.
Mm-hmm.
So to let your shader know that hey, this is the type of input we are gonna get, you have to create an ID attribute for that attribute that is gonna be USD preview surface. And once you do that, then you can create the inputs that your shader node will take. Because each shader node doesn't know what are the inputs that you are gonna get from material. Like you saw how everything is connected. So
Mm-hmm.
when it reaches to material, and from the material when it reaches to shader node, both between them there is no connection about how your data like the attribute values are going to get transferred.
Mm-hmm.
To do that you have to create an argument or kind of a input function into a shader node that hey, there is this USD previous service attribute that we are using in the material, and this is the input that you're going to get from them. And when you do that, the shader will directly take those as input. If you do not use this, shader won't know what is the diffuse color, what is the value you are getting, at
Wait,
what
what
point you
did
are
you
getting.
say? I didn't understand. What did you say? Shader dot create ID attribute USD preview surface, right? And then
Yes.
how is this
Now, first of all,
defined?
tell me how is material connected to shader? That you have to understand first. How is the
How
material connected to shader?
material is connected to the shader by material binding over here.
Right? And when you do material binding, let's say there are some values on your material. How will you
Mm-hmm.
pass on to shader?
There are some values on what?
Material. You are getting some values on material,
Yeah.
right? How will you pass those to your shader network, shader nodes? How will your shader node know that these are the values that needs?
Oh, using this token output surface dot connect.
This is what you're using over here
Mm-hmm.
in USB. But in Python, how will you tell them?
Mm-hmm.
Right? In Python, how will you make sure that the shader gets the correct inputs for the diffuse color, roughness, and metallicness, the
Mm-hmm.
attribute that node is looking for that material.
So shader dot create ID attribute USD preview surface.
Yes, because shader is shader is a property of material that you have to always understand that the material has some properties, but the way the properties are going to get displayed will be through shader. And how will
Mm-hmm.
you propagate those properties to shader? You have to create a node connection between them.
Mm-hmm.
To create a node connection, you have to define that these are the inputs that your shader should take to display the
Mm-hmm.
value. Like basically compile the values. Your material has those values.
Mm-hmm.
You know what I'm saying? So if you take a look at like look at the screen, like look at my screen. I'm gonna show you something.
Oh wait. Yeah.
Now let's again take a look at this handle. Right.
Mm-hmm.
Now you have this handle, and for this handle, you have a material,
Mm-hmm.
right? Or if you do not look at the color or anything,
Mm-hmm.
right? You will be like, okay, this is a handle, and this is the handle that I will be using
Mm-hmm.
as my now when you define the material properties,
Mm-hmm.
right? So you will define some material properties that exist on this handle.
Mm-hmm.
So some of the properties would be diffuse color, roughness, and metallicness of that
Mm-hmm.
material. Now you want to display those values, or though you want to compile those values so that the object can display some kind of properties,
Mm-hmm.
or maybe like how should the object display when you compile it. So
Mm-hmm.
material cannot do that, but the shader API does that for you.
Mm-hmm.
But the problem with shader API is shader API don't know how to where to get the values from. Like
Mm-hmm.
this material has the attribute inside its property spec, right? But
Mm-hmm.
how will you compile it? To compile it, you wrap it with a shader network or shader graph node.
Mm-hmm.
You know what I'm getting? Like, are you able to infer?
Like wrap it in a shader graph node.
Yes.
Like so this node will be responsible for translating the values.
Yes,
Yeah.
translating the values to the shader network. And
Yeah.
the shader, what is the role of the shader? The role
To
of the shader to display,
display. Yeah.
but let's say you do not. So like in the code, if you do not create inputs right over here that the code is creating, and you just wrap it with a shader network. So once you wrap it, shader won't know what to display, what is the value that we are looking for.
Mm-hmm.
So to create a connection between them, you have
Mm-hmm.
you need to make sure that the shader network that you have created or the shader API that you're using
Mm-hmm.
knows what are the inputs that it needs to take.
Mm-hmm.
Shader already knows there are some kind of inputs that it will take, but how will you make sure that only these inputs we need to take?
Mm-hmm.
So to make sure that these are the inputs that we need to take, we will use an input function to create default inputs that you for so basically we're telling shader network that hey, diffuse color, roughness, and metallicness are the things that we're looking to display. That's it. Nothing else from the
Mm-hmm.
material. Even the material might have other properties.
Mm-hmm.
Maybe humidity or temperature or some kind of other things.
Mm-hmm.
That shader does not want. So
Mm-hmm.
to make sure that the shader displays a certain things, you have to create those inputs. And whenever you make changes of those properties onto the material network, the shader will automatically pick them as input and it will display the color.
I see.
So that's why we need to create ID attribute and then inputs for our shaders. And then you
Okay.
have the and then once you have wrapped it into the shader, you have to use create output, like the surface thing over there, to basically showcase the properties directly on your object that you're looking for or that you're trying to load.
Mm-hmm.
That's why whenever we use these kind of APIs, we have to material bind them. If you do not bind them, then it's going to break the system.
Mm-hmm.
Like shader won't know where to pick up the values from first of all, or what material it is looking for, or what material it is going to bind to. So that's why whenever we create inputs, we have to make sure that we are using material binding API
Mm-hmm.
on that specific prim, that okay, these so once you have created those inputs, you need to make sure that okay, this is the material, or this is the cube, or this is the prim that you
Mm-hmm.
want to bind the API. And since there is already material that exists, the USD takes care of that easily and binds the objects based on your needs.
Mm-hmm. Okay. Okay. So create shader equal to USD shade dot shader dot define. We defined our shader over here, which is preview shader,
Yes.
and then we created an ID attribute USD preview surface
Hmm.
shader dot create input. So this was because we created this ID attribute,
Yes.
and then create shader output. Shader surface output is equal to shader dot create output surface, and then SDF value type names dot token. Okay, connect material surface output to shader surface output. Material create surface output to dot connect to source shader surface output. Bind materials to cube. USD shade dot material binding API dot apply cube dot get prim. USD shade dot material binding API cube dot get prim bind material stage dot get root layer dot save. Okay, with texture example, texture RGB output, preview surface, diffuse color input, preview surface output, material surface output. The more a more realistic material use a texture node feeding into USD preview surface. Okay, so we have material wood material token output surface dot connect, and then def shader preview shader uniform token ID token info ID USD preview surface, and then input diffuse color dot connect. So what is this dot connect doing over here? It is connecting to world looks preview world looks wood material wood texture dot output RGB. Okay, I see. So this is getting some input from this place. Wood material wood texture output. So this output of this is getting fed into this, and float inputs roughness blah 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 token output surface. Then what texture uniform token ID USD UV texture uniform token info ID USD UV texture. So USD preview surface and USD UV texture. These are the two shader surface shaders, right?
Yes. Yes. These are two surface shader
And what
schema.
so what was the reason so they are able to give you a set of definitions that you are able to provide to a shader.
Shader node.
Shader node. Okay. And that shader node in turn is connected to um, the
Surface. That shader node is connected to a material. That's it.
material, and then that material is where the prim gets its surface properties.
Yes.
I see. Now I get it. Color 3F, do not use hot code color key distinction. Preview shader is a USD shader prim. Uniform US tells the renderer slash viewer what shader implementation to use. Okay, so this is USD preview surface just tells what shader implementation to use.
Yes.
I
It's an
see.
inbuilt thing. It's an inbuilt thing that it's not a custom thing. It's a
I
completely
know,
inbuilt.
yeah. Is
Yeah.
OpenUSD standard portable preview PBR shader for basic material visualization. It is authored as a shader prim with info ID is equal to USD surface uniform token. Now I get it. Uniform token info ID equal to USD preview surface. Shader type ID used by that node. Basic material visualization ordered as a shader prim. It is authored as a shader prim with info ID, USD preview surface, and connected to a material output surface. Meshes use it indirectly by binding to the material, not by storing shader inputs directly. So it is bound to the material. Now I get it. Perfect.
Yeah, it's a layer cake, I would say. Prim, and then prim has a material, and then material has shader nodes. Everything is
Mm-hmm.
connected via API, and you
Mm-hmm.
are just specifying the shader node. What are the things that you need to take as an input, and
Mm-hmm.
what you have to say using that input, using the output or surface thing, surface
Mm-hmm.
shader to the as an for the object, and when you compile it, it's gonna auto pick it up.
I see. This page is teaching material extraction. Okay, so now let's get back to the actual page. Damn, son. Hmm. Next, we will create the material prim in our stage that has shader surface for material graph. Add the following code underneath material prim. Okay. So material USD shade dot material USD shade dot material dot define. So we are creating a material prim over here. Got it. Create a USD preview surface shader prim. Okay, so this is doing the exact thing that we were reading about USD shade dot shader, and it's creating USD preview surface as the shader prim. Over here, shader dot create ID attribute USD preview surface. Connect the shader surface output as an output to the material graph. Connect the shader surface output. So material dot create surface output dot connects to source shader dot connectable API, comma USD shade dot token surface. Okay.
AI generated shopping bitch.
Okay, let's. I'll be back. Yeah, yeah. Where were we? So we are basically converting the material data and extracting the material data from the fucking OBJ file and converting it into or mapping it into USD rather. Oh, are you able to hear me? Bruh. Bro. Hello, hello. Hello, hello.
Yes.
Bro, look at the chat.
Who's there in chat?
Just look at it.
Oh, bro, fuck it. Bro, we need a moderator. We need a moderator. Tiger is gonna be upset tomorrow. I would be like, that was not good. We should not have said that.
Bruh. I don't know what is he talking about. Happy
Yeah,
birthday to whoever that is, I guess.
Tiger won't be happy again.
Oh, oh my god. So many pull-ups. This pull-up bar is a hack. I'm gonna be jacked soon. Hmm.
What happened?
Look at the chat.
The fuck?
The hell is
I don't know.
Bruh. I want to say something, but I don't want to risk it. Does Reddit get flagged if you know, if you put it on stream?
Ask AI next to you. I don't know.
Oh, okay. Yes, we can use Reddit.
Dude, it's 2:30, so yeah, I will be out by 2:45. If you want to, you
245.
yeah, brother.
Whatever, bro. Okay. It's what is it? 235. Damn. Whew. Hmm. This data exchange shit is too complicated, but it's fine. I'm getting it now. So we have new imports, get material from source mesh, material MTL is equal to scene dot material, mesh dot material index, if not MTL. So asym scene meshes 012 material 012. So for each mesh dot material index, scene dot materials index, source dot material data, sanitize the material name. The code does sanitize material name, tf dot make valid identifier, material name, material path, sdf dot path, sanitized mat name. Why? Because source material names may not be valid USD prim names. The page gives the example that Blender authored OBJ material names like material.001 are fixed. What the fuck is so fucking hot? Yeah, standardize the material name because source material names may not be valid USD prim names. The page gives that the example that Blender authored OBJ material names like material 001s are fixed because the period is invalid and gets replaced with an underscore. Source material name material.001 USD safe material name material 001. So this becomes a valid USD prim path. Material 001 notebook client tf dot make valid identifier and clean source name so they can become valid USD prim name. Creates a USD path. Create USD shade dot material. Material of the conceptual USD. USD material. Shade material is a material container. It's not a shader itself. USD shade dot material package slash container that the mesh binds to. NVIDIA states that material prim serves as a container for material graph. Okay, create the USD preview shader. Mhm. Hmm.
Preview shader. Shader is a touch.
Yes, so first we get the create the material frame, create USD preview shader frame, and then shader USD shade dot shader, USD shade dot shader, define stage material path, append child shader. Fucking code, bro. This fucking code is so complicated.
Yeah, dude, that's why it took me 3 hours. Sat for alone
Connect
earlier.
shader. So I remember. Okay, I understand what this is doing now.
Hmm.
It's basically creating a material prim, a preview shader prim for USD, right? And then it's
Yeah.
converting the material uh, surface output for the OBJ file, and then it is connecting it to the one that we have defined using the
Yes.
connectable API, shader.connectable API.
Yes.
So connect shaders of.
Basically creating a connection to material to shader, shader to surface output. Because shader is the one that processes your colors and everything out over there.
Mhm. First, we get the material info from async using the material index stored with the mesh. So you'll notice that we ensure we are using the valid identifier for the material name. With the valid material name, we create the USD shade dot material and USD shade dot shader. The material prim serves as the container for material graph. In this case, we have just one node in our material graph, USD preview surface shader. So this is the only node we have. And then lastly, we loft the material graph output. Loft the material graph output, this one, by connecting the output surface from the shader prim to the material prim. From the shader prim to the material prim. From the shader prim to the material prim. Shader dot connectable API and then USD shade dot tokens dot surface. Okay. Yeah, I get how they're extracting the material now as well.
Hmm.
So I think okay. Output surface. I see. We have defined the material graph and the primary shader for each material, but at the joint at this point, you shouldn't see any visual difference on the viewport. One point of interest is that the material names were fixed. In this case, TF make valid identifier. Since the OBJ was authored in Blender with material names in the format material 001, the character, the period was replaced with an underscore. You can open the OBJ file in VS Code to see the original material names. Additionally, the expanded output surface property in the material prim showed the connection to the shader prim. Okay. Was replaced with an underscore. Additionally, expanded output surface property in the of the material prim. Output surface property of the material prim shows the connection to the shader prim. Next, let's map the material properties from OBJ to the USD preview surface shader. Copy and paste this code below. We created the shader get color, diffuse color. Okay, color diffuse. Okay, so this is the MTL dictionary, and then we are putting the values for color diffuse inside diffuse color variable
Yes.
and respectively all the variables.
Yes.
Convert specular shininess to roughness. And this is how we are going. Oh, this was a question as well. This was one of the questions in the quiz. How would you calculate the roughness if you
Oh
have
yeah, dude. Same. So yeah, okay. Roughness equal to one minus maths.
square root of material
Yeah.
shininess
I got the
upon
same question in my quiz, and for some reason I was like, okay, I'm gonna go with this option. Like there are three or four options, and I went
Mhm.
with this one. Yeah.
Yeah, I remember I went with this one as well because I remember like roughness would be something one minus shininess or something like that. So I'll just keep this in mind. One minus math or P MTL shininess 1000. Hmm.
All right, bro.
Shader dot here. What you're going?
Yes, brother. You can carry on. I need to wake up early because I need to freaking fix my sleep schedule as well.
But how will you
Okay.
fall asleep if you are not?
I will, bro. I use that military technique. Lord, and I also have some painkillers. I'm gonna take those.
Bruh,
Dude, no, bro. Like literally, it's really fucked up.
I see.
Yeah. Like the thing
That,
is, if I try to sleep, go to sleep right now, I might
mm,
sleep by 3:30.
mm,
If I go to bed by 4, I'm sleeping by 5:30 or 6. That is a
mm.
problem. That's
Yeah,
why.
same.
Uh,
Does ibuprofen?
no, I have the other one, not the ibuprofen. I have the other one.
I want to use it, bro. I have ibuprofen.
It's more of an anti-inflammatory. Ibuprofen doesn't have drowsiness thing or properties.
Sleepiness. Oh my god, no. Damn. I don't have
Alright,
those drugs.
adios, amigo.
Sedation. Alright. Mm, Data exchange, complete, inherit, specializes, complete, glossary, give, quiz, fetch, data from YouTube, 600 playlist, complete that, studying, setup, lawyer consultation, call, 1A, code, your consultation for EB1A. Hmm. Wake up, dancing in the I promise. Right.